Welcome to 5 Minutes VHDL Podcast, the podcast where we talk about VHDL and hardware design. In the last episode, we introduced the concept of driver. Now we introduce the resolution function and we talk about more on driver concept. When you design your hardware circuits, it's a good rule to have a single driver for each signal. Inside an FPGA or an ASIC is mandatory because the modern FPGA doesn't allow you to have a multiple driver on the same signal. But when you need to connect two or more devices on a board, how we can do this? As a classical example, we can think about a memory bus of a microprocessor connected to external memory, where the microprocessor drives much more than one single device of memory. In this case, all the memory and peripherals are connected to the same bus. So we have multiple driver for the same processor because we have connected many chips on the same bus. In the first episode, we saw that we use binary logic to model our hardware. Binary logic means true or false, 0 or 1, but only two values are not enough to model the real hardware situation. Since we need to connect, for instance, an FPGA pin to a memory pin, we need something that allows us to model this situation. Let's see an example with an example on Telegram channel. If you go on the Telegram channel, we can see a single wire bus where two drivers, two pins of two different devices, are connected together. We need to model the situation where a buffer drives high and other buffer drives low. This is the situation on the picture. As you can understand, we should avoid this situation since we are shorting the power supply with the ground. If you think about a driver that drives high as a switch connected to the power supply and a driver that drives low as a switch connected to ground, we are shorting VCC, the power supply, with ground. So how can we model this situation? In this case, we introduce the standard logic and the standard U logic. U stands for unresolved logic. The standard logic types help us to resolve this situation. It is a 9-value object starting from U and ending with dash. U means unassigned. X means short circuits. 0 is 0, 1 is high, 0 is low. Z means tri-state. W means weak unknown. L stands for low, something like pull down. H stands for high, like pull up. And dash stands for don't care. To understand these 9 values, this is the 9 values standard U logic that is provided on the standard logic package 1164. To model the situation where we have two drivers, we need to understand what is the behavior of the circuits when we drive, for example, one buffer to low and one buffer to high. In this case, we have the standard logic type that is the resolved type of standard U logic, where U stands for unresolved. What means resolved type? It's very simple. It's like to play the battleship. In the picture, we can play the battleship in this way. On the left, we we have a matrix with the row on the left with 9 values starting from U, that is the stronger value, ending to dash, that is the weakest value, and the first row starting from U and ending with dash. We have to cross and to understand which is the output of these circuits. Starting from the left, for example, the left column, we can see where is the 0, that is the driving of the drivers on the left, and crossing with the 1, that is the driver on the right, starting from the row, the upper row. With the battleship, we saw that the intersection between 0 and 1 is X. This means short circuits. In the second example, we see that starting with 0 on the row defined with 0 and crossing with the column relative to H, so we have a 0 that drives low the bus, and H that is pull up, 0 fighting with pull up, 0 wins. In fact, in this case, the intersection is 0. This is how the resolution function works. Using the standard logic package, we can resolve and model all this situation. Of course, this is the situation that we can have outside a chip. Inside our FPGA or ASIC, inside our design in FPGA, we shall avoid this situation. In this case, there is the design rule checker that runs after the layout of your code that verify that no such situation will occur. But it is possible to design a VHDL that short inside a device, and this is a problem because you short power supply with ground, and and the risk is to burn your device. Okay, for now and for today is enough. Remember to join the Telegram channel and to leave a review if you want on iTunes. See you on the next episode, and ciao.